In this video, I am going to explain about eigenvalue buckling analysis fixed free column. An aluminium column which have a Young's modulus of 70 GPa built into the ground has length of 2.2 meter and is under axial compressive load P. The dimensions of the cross sections are B is equal to 210 mm and D is equal to 280 mm. Find out critical load to buckle the column. Second question, if the allowable compressive stress in the column is 240 MPa, is the column more likely to buckle or yield? Third question, if the factor of safety affects 1.95, what is the allowable buckling load? So we have to find out these three questions. So first of all, I am going to discuss about the analytical calculation before moving to Ansys Workbench. So the Euler's buckling formula PCR equal to pi square EI by LE square, where LE is the effective length of the column. For a fixed free column, the effective length is LE is equal to 2L. So we have 4.4 meter. Next one, the column may be buckled about x-axis or y-axis. The moment of inertia for rectangle is we have I base into height q by 12. So for about x-axis, 210 into 280 q by 12, we have 3.84 into 10 raised to 8 mm raised to 4. About y-axis, moment of inertia about y-axis, 280 into 210 q by 12, 2.16 into 10 raised to 8 mm raised to 4. So smaller moment of inertia we will take. Then the critical load based on Euler's buckling equation is, so putting all the values here in this equation, and we have a result of 7,700 kilonewton. So next one, we are finding out the buckling stress. Buckling stress is critical buckling load divided by the area. Area means B into D. So buckling stress is 7,700 into 10 raised to 3 divided by 210 into 280. That means 130.95 MPa. So we already know that if the critical buckling load is less than 240, 240 means that is the compressive strength of the material, aluminium, the column will buckle. If the critical buckling stress is greater than 240, the column will yield. Then the factor of safety, we have already given that the factor of safety is 1.95. The factor of safety is failure load divided by allowable load. Then the allowable load is 7,700 divided by 1.95, 3,954 kilonewton. So this is the result from analytical calculation. So I am going to perform the eigenvalue buckling analysis in Ansys Workbench and finding out the critical load. So this eigenvalue buckling analysis always start with the static structural analysis. Click on engineering data. Type the material aluminium. Click on isotropic elasticity. Young's modulus change to MPa 70000. Poisson ratio 0.3. Then compressive strength, it is also in MPa, 240 MPa. Then go to geometry, right click, select design modeler for create the geometry. Click on XY plane, then change unit into millimeter, sketching, select rectangle. So H is equal to 210 mm. Here V is equal to 280 mm. Extrude 2200 mm. So we have the beam. Minimize it. Click on model. So this is the beam. Here select solid, change the material into aluminium, then mesh, generate, then click on static structure, fix it, this side, okay. Then in top side we are applying the load, force, click here, change vector into components, then check z-axis in downward direction. So here you have to give the value 1. So why we are given the value 1 is we have a load multiplier. I will explain later when it reach. We have a load multiplier, that's why here 1 is giving, and the direction is correct, it is in downward direction through z-axis. Then click on solution, solve. Okay. Then minimize it. Right click setup, transfer data to new, right click solution, transfer data to new eigenvalue buckling. Then click on setup. See, you can see that here eigenvalue buckling analysis will be here. Okay. Then in analysis setting, we have maximum mode to find. Default will be 2. We can change it to 2, 3, 4, 5, etc. I will keeping it as 2. Then again solve. Click on solution. See, this is the value, that is the critical load, 7,740 kilonewton, 7,740 kilonewton. So we are already provided 1. That's why the critical load will be 7,740 kilonewton. So this is the load multiplier. Okay, that's why I given later I given the force as 1 value. Okay. So this is a value we have get, that is 7,740 kilonewton. Okay. Suppose we have to find out the deformation, total deformation. Then this is the total deformation, and we have 2 mode. Actually, we have 2 mode. So this is the first mode and this is the second mode. Okay, if we have changed the mode to 5 number, we have 5 numbers of mode will be there. Okay, so the value critical load in Ansys Workbench is 7,740 kilonewton. So from Ansys Workbench, we know that critical load is 7,740 kilonewton. Using this value, we are calculating critical buckling stress, that is 131.63 MPa, and the allowable buckling load, that is 3,969 kilonewton. And we have a comparison between the result by Euler's equation and Ansys Workbench. The parameters are critical load, critical buckling stress, and allowable buckling load. So this is the parameters result from Euler's equation, and this is the result based on Ansys Workbench. Okay, thank you.